All right, a monomial. Do you know what mono means? One. Yes. Yes, it is a disease. You can get it from kissing one person. All right, now, a monomial is just a single term. Mono means one. Mononucleosis, maybe that's like one strand of bad stuff. I don't know. I'm no doctor. All right, now, a monomial can be either a variable, or it can be just a number, or it can be the product. Product means multiplication. The product of both of those, like a number and a variable. Okay? All right, now we're going to talk about the degree of a monomial. And the degree of the monomial is going to be the exponent of the variable. Exponent of the variable. Okay? Not just the exponent, but the exponent that's on the variable, not the number. Okay? So I'm going to give you some examples of some monomials, and then you're going to tell me, or we're going to talk about what the degree of that monomial is. So here we go. 5x. That's a monomial. That is either a variable or a number or the product of both of them. It's the product of both of them. That's a monomial. It's one single term, and the degree is the variable exponent, which is 1. This is x to the first power. We don't write a 1 there, but we know it's there, right? It's to the first power. Okay, how about something like this? Negative 10x to the 6th. That's a monomial with degree 6. Perfect. Degree 6. Okay? How about your favorite number? 5. Okay? What's the degree of 5?
0.
0. Remember, it's the exponent of the variable. This has no variable. Its degree is 0. Tricky. X has a variable. It's x. 5 is not variable. You know what variable means? Variable means it can change, right? If something's variable, the weather is variable. It changes. If something's constant, it doesn't change. 5 is not variable. 5 is 5 all the time. All right, how about this one? We studied some of these last chapter. 1/3 x squared. What's the degree of 1/3 x squared? 2. It's degree 2. Okay, how about this one? 3 to the 4th power. What's the degree of that one?
0.
Good. I tried to trick you because that's what math teachers like to do. There's no variable there, but I did put an exponent. The variable, or there's no variable, so the degree is 0. 3 to the 4th is what, 81?
Yeah.
Okay. Now, some things that are not monomials. Those are all monomials, okay? Something like this, 2 over x cubed, that's not a monomial. When you have the x in the denominator, that's something totally different that we'll study later. Don't worry, we're going to still study that. They're not monomials, though, okay? Something like this, 3x to the negative 4, that's not a monomial either because the exponent is negative. We can't have negative exponents. Something like this, the square root of 3x is not a monomial. Okay, we can't have square roots with x in it. Those are not monomials. Now, a monomial, what it looks like in standard form is this. A x to the n, where n is going to be a counting number. Yeah, you have to know what those numbers were. Remember, real number, irrational, rational. That was the first day of school. You have to know that stuff. A counting number. So n has to be like 1, 2. Actually, it could be a whole number because n could be 0. Well, whatever. Okay, now, polynomial. Well, do you know what poly means? Yeah, many, right? That's why that restaurant I used to work at is called Polly's Pies. Many pies. All right, so polynomial. That's a joke. It's actually Polly's. She's like an old lady, but. All right. Polynomial is going to be a monomial. You again. I won't kick you this time. A monomial. Thank you.
Can you see if it's her phone though?
Oh, okay. Hold on. Let me pause. Pause the video. So you need some more of that? Okay. All right. Now, a polynomial is a monomial or the sum or difference of monomials. Okay, so difference of monomials. So you can get something with a whole bunch of terms in it, and we're going to talk about what those look like. So a polynomial is a monomial. Okay, so monomials are all polynomials, but then you can have one that has like a whole bunch of terms all added together. Now, the degree of the polynomial is going to be the largest degree of the monomials. Okay, you're not going to add them up. You're going to look at all the terms, and you're going to say, who has the largest? Oh, this one does. That's the degree of the whole thing then. Yeah. Kind of like people with money, you know, the one who has the most money, they always win. Okay, so here we go. Polynomials. I'm going to give you some examples, 3 different examples of a polynomial. So here we go. We studied these. 2x plus 3. That's a polynomial. It has 2 terms, and the degree of that is 1. It has degree 1 because the first monomial of it, 2x, has degree 1. The second monomial, which is 3 of it, has degree 0, so 1's bigger than 0, 1 wins. Okay? All right, something else like this. 5x to the 4th minus 3x to the 9th. That's a polynomial. You know what? I'm going to add on something here. Plus 2. It doesn't make any difference. Yeah? 1. Yeah, that's a 1. It's weird, huh? It's a 1. All right, take a look at that polynomial. Okay? What's the degree of that polynomial? 9. Yeah, perfect. It's 9. Degree 9. It's the largest degree of all the monomials in it. All right, now write this one down. You're going to love this one. X to the 3rd minus 10 plus 8x squared plus 5x minus 7x to the 4th. Okay, a couple of things. We're going to answer the question, what's the degree of it? But doesn't that look like just a jumbled mess of stuff? It really does. We don't like that. It has no order, has no rhyme or reason. But the degree is what? 4, exactly. The degree is 4. But yeah, if you look at that, it's awful. It's just a bunch of stuff all messed up. So that's why we like to come up with something called the standard form of a polynomial. The standard form of a polynomial is the way that you usually like to write your polynomials. And that's when you have descending order, descending degree order. Okay? Descending means it's going down. It's getting less and less. And then the leading coefficient is going to be the number out front when you are in standard form. Okay? So descending degree order, and it's the number out front, the leading coefficient. It's leading the pack. But the leading coefficient is only leading coefficient when it's in standard form. So let's go ahead. See this third polynomial right here? Change the color. Third polynomial, this guy right here, we're going to take that and we're going to rewrite it, put the third polynomial in standard form. So we're going to take the biggest exponent, put that first, the next one down in descending order, okay? So for this one, we're going to do negative 7x to the 4th. The negative goes with the 7, by the way. Negative 7x to the 4th plus x cubed plus 8x squared plus 5x minus 10. And that should feel better to you. It just looks better, right? Because then I know how long it's going to be if it's in descending order. And what's the leading coefficient? What's the LC, the leading coefficient? Yeah, it's negative 7. It's this number out front that's leading all the rest of the polynomial. Okay? Negative 7. All right, now I'm going to go ahead and give you some words, and you got to know these words for next Tuesday. And so we are going to classify a polynomial, and we're going to do that 2 ways. The first way is by its degree, and the second way is by the number of terms that it has. Okay? So here we go. We're going to go all the way up to degree 5. So we'll start at 0. If a polynomial is degree 0, then we call that a constant. And that would be just a simple number. So for example, my favorite number is 14. Someone else's favorite number is 14. No? I thought so. Never mind. All right. If it's degree 1, if our polynomial is degree 1, we say that this polynomial is linear. Do you know why it's linear? Because it's a line when you graph it. So something like negative 3x plus 2. If you were to graph y equals negative 3x plus 2, hopefully you know how to graph that. That's a line. Okay, we just spent an entire chapter, go ahead, doing degree 2 polynomials. Yes, and what was that formula that we used? Quadratic. So these are called quadratic. And so an example of quadratic could be something like negative 10x squared. Okay, I could have more stuff on that, but negative 10x squared is a quadratic. All right, when you raise something to the third power, what do you do to it? You cube it. So these are called cubic functions. Okay, and the cubic polynomials, they might look something like this. 2x cubed plus 3x squared minus x plus 1. Okay, that's a cubic function. It's got a lot of terms, doesn't it? They could have 1 term, 2 terms, 3 terms, at most 4 terms. Now, a 4th degree polynomial, how do you split up a gallon into 4s? What are they? Quarts. All right, this is quartic. Quartic. So a quartic is going to look something like, maybe you have 3x to the 4th plus 2x squared, and that's it. Okay? So that's a quartic because it has degree 4. 4 is the largest degree of any of its monomials. It's quartic. And then finally, the last one, there's actually 2 ways to say this word. I usually say quintic. Some people say quintic. It's really up to you. But there used to be these little dolls called the quints, and they were all 5 of them. And they were all dolls together. It was gross. I don't know who wants 5 babies at once. Oh, my friend has 4. She loves them, her quads. 4 kids, yeah, one time. All right, quintic. And so this would be something like negative x to the 5th plus x squared minus 4, something like that. But as long as it has degree 5. Okay, so you have to know those names. So 0 is constant, 1 linear, 2 quadratic, 3 cubic, 4 quartic, and 5 quintic. All right, now we're also going to classify them by the number of terms that they have. We'll do this in green. The number of terms that they have. We're only going to go with 3. So we've already done this one. If it has 1 term, it's called a monomial. Mono means 1. 1 term, it's a monomial. So something like 50x. That's a monomial. It has 1 term. Yeah. Yeah, you're not feeling good? Oh, yeah. Okay, number 2. If it has 2 terms, if you speak 2 languages, you are what? Bilingual. Yes. So 2 terms would be binomial. Bicycle, right? Other. Don't say it. I don't know. All right, 3. 3. If something has 3 sides, we call it a triangle. So this would be a trinomial. Tricycle. Trinomial. Oops, I forgot to give you an example of a binomial. A binomial could be negative 3x squared minus 1. That's a binomial. It has 2 terms. A trinomial could look something like this. X to the 5th minus x plus 10. That's a trinomial. It has 3 terms. Okay? And then if anything is like 4 or more, we just call it a polynomial. They're all polynomials, by the way. Even monomials are polynomials. But some of them have special names. Monomial, binomial, trinomial. 4 plus is a polynomial. All right, are you ready to do some in action? All right, so flip your page over. We are now going to fill in the chart on the back. And the chart on the back, you're going to have a chart just like this, probably smaller, not as many questions, on your quiz next Tuesday, okay? So be aware of that. All right, so let's move. Here it is. Now, what we're going to do with these is we first are going to get this in a standard form, okay? Sometimes it's going to be easy. Sometimes we're going to have to combine like terms. Sometimes we're going to have to FOIL. But we're going to get it in the standard form, and then we're going to answer the question for each of these. So standard form for 17x is simply 17x. Nothing to do there. Pretty easy, right? And then what is the leading coefficient of this polynomial?
17.
Yeah, 17. Perfect. And the degree? 1. Okay? And now be careful. The name of the degree is the name that, degree of 1. This would be linear. And the name according to the number of terms that it has 1 term, so it is a monomial. So you got to know these words by Tuesday. Okay? All right. Now, that was an easy one. Nice little warm-up, make you feel fuzzy and warm. Let's do number 2. Number 2, we need to write this in standard form. But as you can see, I've got some like terms I need to combine. So if I have 1x cubed plus 3 more x cubes, how many x cubes do we have? 4x cubed. Perfect. So you get 4x cubed plus 5. And that's in standard form, descending order of exponents. All right, so what is the leading coefficient here? 4. Good, that's the number out front. And the degree is 3. And because it's being to the 3rd power, its degree says that this is a cubic function. Binomial. It's got 2 terms, right? 2 terms, so it's a binomial. Yes, very good. I'm going to let you try the next one. Okay? By your little selves, just real quietly. Yeah.
What if it's more than 5?
Ooh, if it's more than 5, we don't know those words. You can look them up, but we don't go that far. This book just goes to 5. Yeah. 6 or 7, 8. You can probably guess what they are, but we won't. Just 5, up to 5. All right, so what do we got? We've got negative 3x to the 5th minus 5x cubed plus 2. Kind of ran out of room because I write kind of big. Nope, you can't combine any of those because they have to have the same exponent and the same variable. All right, so what's the leading coefficient here? Negative 3. Good, yes. You even said the negative parts. Negative 3. This is a degree 5 polynomial, which is a quintic. When you have a quinceanera, is that 15? See, the 5, kind of quince, quint, kind of sounds a little bit the same.
I thought it was 16.
It's 15.
No, it's 15.
Okay, and then it has how many? 3 terms, so it's a trinomial. Tri means 3. Tricycle. All right, now number 4 is not slight work. It's a lot of work, okay? So let's do number 4 together, and I'm going to show you the game plan on number 4. We have to take x plus 2 and multiply it times itself. A lot of people think that that's just x squared plus 4. A lot of people are wrong. It's not x squared plus 4. When you take x plus 2 and you have to multiply it times itself, you have to FOIL that. Okay? So that's our first step. We're going to FOIL this out. Here we go. X times x is x squared. If he hits you, just kick him. Okay? And then plus 2x, plus 2x, and then plus 4. Because guess what? Then he won't do it again. Yeah.
You're right. You're right.
Yeah. All right, so we get x squared plus 4x plus 4. Now that's just the first part, okay? I'm going to write that in blue. That's just what I underlined right here. That's just that part.
You see?
Yeah, he totally necked you.
I'm definitely kicking you out.
No, we're even. I think you did something earlier. Maybe you should move up one desk. All right, so now minus. That was on video, great. Minus. All right, so now let's take x minus 2 times x plus 6. And we got to FOIL that out too. Okay? I'm going to leave the minus in the middle, and I'm going to do that later. So let's FOIL this out. I was going to do a different color, but you guys distracted me. X squared plus 6x minus 2x minus 12. Are you getting really good at FOILing? You're getting pretty good at it? I hope so by now. Yeah. Almost to second semester Algebra 2. You're doing pretty good. So then we get x squared plus 4x minus 12. Okay. Now notice, from the first one that I FOILed out, I got this whole thing. From the second one I FOILed out, I got this whole thing. And now I need to subtract them. Okay? And it's really cool, because a lot of things are going to cancel each other out here. So you have an x squared minus an x squared. You know what happens? Those cancel each other. And then I have a 4x minus another 4x. Gone. And then at the end, I have 4 minus negative 12. What's 4 minus negative 12? 16. After all that, guess what? 16. Crazy, huh? Okay, so that polynomial is simply 16. And so the leading coefficient is 16. The degree on that polynomial is 0. It's just a number, and all numbers are constant. And then this would be a monomial. Yay! That was a lot of work though, huh? Yeah. Okay, finally the last one. Let me show you the last one, number 5. This one, if you get confused with all the minuses and stuff, you know what you can do is you can just distribute the minus to everything and get rid of your parentheses. Okay, so we have x squared plus 2x plus 4. I can just write that as x squared plus 2x plus 4 without the parentheses. And now I'm going to subtract x cubed. No, that's a cubed, huh? Yeah. Wow, I couldn't see that. My eyes are old. X cubed, I have glasses. They're sitting in my purse. So we get minus x cubed, minus x squared, and minus 4. But the minus is being distributed to all. Yeah. Okay, so I got rid of all the parentheses by distributing the minus to the second part of it. Okay, so now we have x cubes are gone. What else is gone? I see something else I can get rid of. Yes, 4 minus 4. And so I am left with a negative x squared plus 2x. Are those like terms? Say no.
Yes.
No. There's always one. All right, so we get negative x squared, what was it? Plus 2x. Now, you fill in the rest. Okay, I did all the hard work for you. You fill in the rest of it. You can do it. All right, let's do it. And so the leading coefficient, ooh, who got the leading coefficient? What'd you get? Negative 1? Yes, negative 1 is our leading coefficient. And then this is a degree 2. It's squared. Degrees 2, we just studied these. These are called quadratics. Quadratic. And it has 2 terms, so it's a binomial. All right, halfway done. Okay. Any questions on that? That's pretty good, right? You just know that you have to study some terms and figure it out, but it's not hard. So here we go. Next page. Sorry. Now we are going to do 5-2. Here, did you want this? Ooh. Right. Now we're going to do 5-2. Whoa!
What the?
If you're like wondering what's happening, it's really raining outside. Everyone's going crazy. By everyone, I mean me. Okay, here we go. Oh. Okay, so lesson 5-2 is all about polynomials. We're going to be studying this whole chapter of polynomials, but we're going to talk about its linear factors and the zeros of a polynomial. Some of this you already know how to do, you just don't know you know how to do it yet. Okay, so polynomials, we can have them in 2 ways, either factored form or standard form. All right, these right here, number 1, those are all in standard form. And so it says here that if a polynomial is set equal to 0, then those are going to be the zeros of the polynomial. Okay, so I'll show you what that means. First of all, for number 1, we're going to write the polynomial in factored form, and then we're going to find its zeros. So you know how to factor, yes? We spent like, a whole week. Yeah, you do. A whole week on factoring.
But you know.
I do. I know how to factor the right way. All right, so let's go ahead and we're going to factor out. Yeah. Always factor out the GCF first, okay? So in this case, we have a greatest common factor, and what is it?
X.
Good. So take that x and factor it to the front, and then we're left with x squared minus 2x minus 15. Now we're going to factor it some more, because this is not a linear factor yet. This is a quadratic factor. We need to factor it all the way into its linear factors. And you can use star method, but you don't have to. Did you realize that? If you have a 1, leading coefficient of 1, all you have to do is go, what times what's negative 15 adds up to negative 2? How about a negative 5 and a positive 3? Okay? You don't need star method or triangles and circles. You don't need any of that. Okay, so we did the first part of this question. It says write the polynomial in factored form. Did we write it in its factored form? Yes. Now the second part is to find its zeros. Finding its zeros mean, like if this was equal to 0, what would make this polynomial 0? There's 3 things that would make this polynomial 0. Does anyone know them? 0 from this first factor, and then what? 5, negative 3. Perfect. It's like what you did on your test, right? You set it equal to 0, you factored it, you solved it. Now we have 1, 2, 3 of them. Yeah?
I thought like if it was positive, it's supposed to be 2 solutions. If it was 0, there's only 1, or if there's negative, there's none.
No, this is a cubic, so it's different. Cubics are going to have 3 solutions when they're factorable, and when they're, like sometimes they don't, but most of the time they're going to have 3 solutions. 3 real solutions. They always have 3 solutions. Okay, let's try another one. Here we go. Go ahead and factor this one, okay? Factor on x first. I'll do it with you. We factor on x, we're left with x squared minus x minus 12. Can we factor some more? Sure. Factor that. You can use star method if you really like it. Here, we really don't need to. So you say what times what's negative 12 adds up to negative 1, negative 4, and positive 3. Okay? And now they want us to tell what all the zeros are. So the zeros are going to come from the factors. From this factor right here. See how it has 3 factors? That's 1, this is 2, and this is 3. From my first factor, what could make that 0? 0. Not a trick question. It feels like it. But 0 goes in, everything else is 0. From the middle factor, what would make that 0? 4. And then from the last factor, negative 3. So those are your 3 answers. Okay? It's just like the stuff you did last chapter, but a little bit extra added on. All right, let's try C. You want to try C on your own? No, not today. All right, I'll try it with you. I like these enough for all of us. Let's factor out an x. We're left with x squared minus 9. Can we keep factoring?
Yeah.
Yeah. What does that factor as?
X minus 3.
Perfect. Doesn't matter what order that's in. X minus 3, x plus 3. And so now let's say what the zeros are. What would make this polynomial equal to 0 would be 0 and plus and minus 3. You could separate them if you want to. Okay? So that's how you find the zeros of a polynomial. You want to have it in its factored form and just find the individual zeros. Okay? All right, now we're going to go backwards. And so it says here, if x minus a is a factor, then a is a 0, but there's an if and only if statement which says it actually goes both ways. So do you remember on your test the bonus question? Yeah, you had to work backwards, huh? That's what we're going to do here. All right, it says here, write the polynomial function in standard form given its zeros. I'm going to change this, okay? So I don't like this question. I'm not going to have that as a 2 anymore. I'm going to have that as a 1, okay?
Well, you can't do that.
I can. I just did. I didn't do this earlier, but I should have. Okay. So negative 2, 3, and 1. Did you already do it? Oh, okay. Now it says, write the polynomial function in standard form given its zeros. Now, I'm not going to jump straight to standard form. I'm going to write it in its factored form first, and then I'm going to FOIL it all out. So if negative 2 is a 0, that means the factor that goes with that is x plus 2. It's the opposite, right? If 3 is a 0, then x minus 3 is the factor that goes with that one. And what would be the factor that goes with 1 as a 0? X minus 1. Do you get the idea? It's going backwards. So see here, we had factors, and these were the zeros that went with them. Now I have the zeros, and I have to tell you what the factors are instead. It's the opposite way. And now we get to FOIL this. Yeah?
I don't get why you changed it to 1.
Well, I'll tell you why. It was x minus 2 and x plus 2. And when you FOIL that out, you get x squared minus 4, which only has 2 terms, and then you have to FOIL again. When you do this in your homework, because someone came up to me after the notes and said, I don't know how to do this. It was something that had 3 terms times something that had 2 terms, and I didn't give them one of those in the notes. So I changed it.
Oh, so you
Yeah.
didn't, like,
Instead of positive 2, I changed it to positive 1.
oh, that's, you can't, like, if I get a problem, I can't do that.
No, I did it. I did it, yeah. No, you can't just change it. You're right. You're right on that. You can't just be like, no, I don't like this problem. I'm going to do this one instead. Don't do that on a test. Yeah, you'll get it wrong for sure. Okay, so here we go. How do you make this into standard form? Right now, this is in factored form. I need to get this in standard form by FOILing the first 2. So let's FOIL. You ready? X times x is x squared minus 3x plus 2x minus 6. Okay, I just took the first 2 and now simplify that, and you get x squared minus x minus 6. All right, so now I'm going to take that whole thing and multiply it times x minus 1. I like to call this super FOIL. It's pretty awful. It takes a while, okay? But if you just are good at organizing things and, doing it one step at a time, you'll be fine. Take that x squared, and you're going to multiply it by both terms in the other one. So x squared times x is x cubed, and x squared times negative 1 is negative x squared. Okay? Now I'm going to take the middle term, which is negative x, and I'm going to multiply that by both things. Okay? So negative x times x is negative x squared, and negative x times negative 1 is positive x. And then finally take negative 6 and multiply it to both terms to get negative 6x plus 6. It's a really terrible problem, isn't it? You're going to have one of these in your homework. All right, so you get x cubed. Combine your like terms. If I have a negative 1x squared and another negative 1x squared, that means I have negative 2x squared. And if I have a positive x minus 6x, that means I have negative 5x and then plus 6. That would be the answer. Whew. Terrible, terribly good problem. Really good. Okay? That's called super FOIL. Yeah, it's not slight. Okay, let's go over here. Now we're given 3 zeros again. This one's a little easier. And these 3 zeros, the factors that go with these, when I have 0 as a factor, that's just going to be x. And then you know what happens is I have 4, and I have 4 twice. Okay, so you could write it as x minus 4 times x minus 4. That might be a little bit better. You might like that. X minus 4 times x minus 4. And now we get to multiply all of this out. Yeah, it's not as bad as the other one, though. Okay, So here we go. Let's go ahead and let's multiply x minus 4 times x minus 4. Can you do that middle step in your head? I'm going to watch you try. Okay? We're going to do that middle step in our head. We're going to go x times x is x squared. Outside is negative 4x. Inside is negative 4x. What does that give me? Negative 8x plus 16. Are you that good yet or not yet? No? Okay. And then distribute the x to everybody, and you'll get x cubed minus 8x squared plus 16x. And that would be the polynomial in standard form. They take a while, though, don't they? Do you like factoring better than foiling? Yes. Me too. Yep, they're both F words, though, aren't they? That's a funny joke, okay? Parents, I'm sorry. All right, here we go. Now we're going to talk about the multiple zeros. Multiple zeros. Do you need a break? Do you need a stretch?
Yes.
Yeah. Here we go. Now, a multiple zero is going to be a repeated zero. A repeated zero. Okay? I kind of am a repeated person. I have a twin, right? If you're triplets, you are repeats. Pete and repeat are the twins, right? Except if they're Spanish, they're Jose and Josbe. All right, so now the multiplicity is going to be the number of times a zero repeats. The number of times a zero repeats. Now, a zero cannot repeat one time. Repeats, okay. So you can't say, oh, it has a multiplicity of 1. Nobody will ever say that. Multiplicity is multiple, 2 or more. Okay? It's funny because there's a movie called Multiplicity. It's way before your time. It's Michael Keaton, and he clones himself. And it's called Multiplicity because there's all these Michael Keatons. Okay. Do you know who Michael Keaton is? He was a Batman. One of the Batmans a long time ago. All right. Here we go. We're going to find the zeros, and then we're going to state their multiplicity. Okay? So here we go. I'll show you how to do this. Now, the zeros are found very easily when it's already factored for you. Okay? So, right here, the zeros are going to be 2 and negative 3. Do you all agree with that? 2 would make that 0. Negative 3 would make that 0. Now, what happens, though, is negative 3, that 0, is x plus 3 and x plus 3. So how many times does that happen? Twice. So negative 3 has a multiplicity of 2. Okay? So 2 is a 0, true. Negative 3 is a 0, but it has a multiplicity of 2. It happens 2 times. Let's look at letter B now. Okay. This one has a lot of multiplicities here. So our factors from this one are going to be 0, our zeros are 0, and negative 1. Now, how many times does 0 occur? 4 times. It has a multiplicity of 4. X to the 4th is x times x times x times x. It has a multiplicity of 4. Okay? It's the same 0. It just happens 4 times. Yeah. How many times does negative 1 happen? 5. I almost tricked myself. See, it's 3 here, but then it's 2 there. Oh, it's the same one. So that one has a multiplicity of 5. Okay? I'm going to add one right here. If I have something like this, x minus 10 to the 7th power, okay? What would be the 0 of that polynomial? 10. How many times does it happen? 7 times. It has a multiplicity of 7. What's the big deal with multiplicities? They actually affect the graph. Okay? They do. I want to show you real quick. Before we get to letter C, I want you to get your calculator out, and we're going to graph this right here. We're going to graph this. Have you ever graphed a cubic on your calculator before? No? Oh, this is such a good day for you. So exciting. All right. Graph this right here. Do you know how to do the x to the 3rd? You use the caret button. Okay, let me show you. You go x, and the caret is right here. It's underneath clear. Caret, x to the 3rd. And then if you need to get down from there, you arrow over to the right. Okay? X to the 3rd, what was it? minus 8x squared, and then plus 16x. Now, this polynomial, it has 3 zeros, 0, 4, and 4, okay? So let me show you what they look like when you graph them. Hit zoom 6. Ooh, okay. Do you see how the polynomial went through 0, but then it just bounced off of 4? What does it look like right there? It looks like a parabola because that 4 happens twice. It's like a squared. It's like a quadratic there. Isn't that cool? That's why. Yeah, really cool. If it wasn't a multiplicity, it would have done something like the other one, which didn't have any multiplicities at all. Let me show you that one. 2x squared minus 5x plus 6. When I graph this one, watch this one. It's just going to go through, and through. It didn't bounce off of anything at the x-axis. So this one, do you see what the zeros are? The zeros were -2, 1, and 3. They're the x-intercepts. Yeah?
Can you go back to what you were plugging in? Because it looks like you plugged in x. Why did you plug in x to the third when it's x to the fourth?
Oh, I went back to this one up here.
Oh.
Yeah, I was graphing that one right there to show you. This one would be crazy if I graphed that one. Do you want to graph that one? Let's do it. This is a 9th degree polynomial. Let's see what happens. We have x to the 4th, parentheses, x plus 1 to the 3rd, and then x plus 1 squared, which we could have combined them together, but it doesn't matter. All right, and let's graph this one. It's going to go through 0 and -1. Oh, that's boring.
If you do C, it looks a lot better.
Yeah? C's a lot better? That was boring. I was expecting so much more. Ooh, yeah, that's a good one. Let's do that one. Okay, first we need to factor it. Let's factor this one, then we'll graph it. So if you factor this one, you want to factor out an x squared. And you're left with x squared plus 6x plus 8. Now, I think we can all agree, Michael, can we all agree that we don't need any of our magical ways to factor this?
No.
We don't, right?
We do.
No, we don't. All we do is say what times what is 8? That adds up to 6. 4 and 2. 4 and 2. Okay? We can go straight there. If the leading coefficient is 1, just go straight factor. And so you get 0 is a 0 with the multiplicity of 2. And -4 is a 0, and so is -2. Yeah, let's graph that one. That's a great idea. We'll go x to the 4th plus 6x cubed, and then plus 8x squared. Let's see what that looks like. And graph. It's going to go through -4 and -2, and then it's going to bounce off of 0. Because 0 happened how many times? Twice. You see how it looks like a parabola there? See how through here it looks like a line, and it looks like a line, and then here it's a parabola? Yeah. We actually focus a lot on that in HAM. So if you want to take Honors Advanced Math next year, we really dive into polynomials. Super exciting. Are you thinking about second semester already? Yeah? Yeah. There's been announcements about your schedule and stuff. So take a look at it. Make sure if you have any changes, you contact Mrs. Pfeiffer. Okay. Last page. Here we go. Are you ready for it? Now, as you noticed when we graphed some of these, okay, the graphs are going to look very interesting. Polynomials are beautiful. You know why? They're so curvy. I mean, I don't want to say that in a perverted way, but they're like curvy in a way that they don't have any breaks or jagged edges. You know, I'm not talking about like curves. I'm talking about like a function and the way it looks. So like a polynomial that has a degree 3 might look like this. Oh, look how beautiful that is. Okay? And that's a polynomial. And that would probably be a cubic function. And what we do is we can find the zeros because the zeros are just simply the x-intercepts here. Okay? If we graph them. We can also factor them and find the zeros that way too. Now then there's going to be 2 other special points on this graph. I'll show you what they are. This one right here, and this one right here. Why are those so special? Yes, okay, but they're not, they're almost that. So this is called the relative maximum. So you were right. It's a relative maximum, and this is a relative minimum. Now, why relative? Ooh, good call. Exactly. Did you hear him? He said because the graph still continues. It's still going to be farther up. It's going to go up forever, and it's going to be lower than that point. But in that neighborhood, I know it's kind of funny to talk about neighborhoods, but in this neighborhood, it's a maximum. That guy's sitting at the top of the hill looking down on all the peons, right? And this one, he's at the bottom of the valley. Okay? This is also really important when you do physics. What happens when you reach a maximum and you start coming back down? What's that right there? What's the velocity equal?
Height.
Nope. Velocity, like you're accelerating, you're slowing down, and then it goes to 0, and then it starts to speed back up as it comes down. So these are very important points right here in physics and calculus and all kinds of stuff. And guess what? Our calculator is going to find them for us. So here we go. I think we're just going to do A. I'll see how you do. But go ahead and plug this in. We're going to graph this in our calculator. Okay? We're going to sketch a graph of this. We're going to find the zeros, and we're going to find the relative max and the relative min. So start by graphing on your calculator, okay? Hopefully you have your calculator so you can practice these. If you haven't taken it out yet, please take it out. So here we go. We're going to graph 2x cubed plus 10x squared plus 12x. Everyone okay? All right, and when I graph that, is it big enough? Oh yeah. Sometimes you might need to adjust your window, okay? So you have to go to a bigger Y or a smaller Y because you can't see the top or the bottom of it. You might have to adjust that, okay? But here I don't have to. So I'm going to find the zeros right away. Do you remember finding the zeros? They're your intersections with y2 equals 0. Yeah, you can see them on your calculator. They're pretty easy to see. If you forget, you can always calculate the intersect. And you get 0 there, calculate the intersect. You get -2 there, and then you'll get -3. They're going to be nice numbers usually for those, okay? So let's go ahead and draw a sketch of this. So I have -2, -3, and 0. And this graph goes up a little bit, down a little bit more, and through. And draw it like a nice smooth curve, you know, no breaks, no discontinuities. It's really nice. So -3, -2, and 0 are the zeros of the polynomial. They're the x-intercepts. Now, that's not new, okay? You did that last chapter. You had to find when the quadratic equals 0 by graphing. That's exactly what I did, but I found 3 numbers instead of 2. Now we're going to find the maximum and minimum, okay, relative. So here we go. Let's find the maximum first. Here is the relative maximum, okay? So go to your calculator and go to second trace. Second trace is where you're going to calculate things. And what number do you think we're going to press here? We're finding the maximum, 4. Number 4, the maximum. Okay, now watch. Your calculator is going to ask you a question. It's asking you left bound. Right now, my blinker is blinking over here. Is this the left side of the maximum? No. Watch. If you were to break this up into 2 sides, do you know your left and right? Yes. This is the left side, and this is the right side. So I want to arrow my cursor over till I'm somewhere over here for the left side. Do you see that? It's asking me left bound. Now I'm on the left side. And then you'll hit enter. And then your calculator, what it did was it just drew this little arrow to tell you that it wants to go nothing beyond that once you go to left. Now it's asking you right bound. Are you on the right side over here? No. Arrow over until you are now on the right side and hit enter. And then your calculator puts a triangle here. And now it's going to find the maximum in that little area that you gave it. And so it's asking you, should I guess what it is? Sure. Hit enter one more time. And the maximum is negative, we'll write this down. The maximum's a point. It's negative 2.55, 1.26. Okay? Now, you can't just hit enter, 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 like you do for your intersections. Yeah?
I got the wrong answer.
Yeah, actually, that.
Yeah. 100%. We'll do it again. We'll do the minimum, see if you can get it that time. Okay? All right, so here we go. Do you see where the minimum's at? The minimum is right here. This is the left side of the minimum. That's the right side. So here we go. Go back to your calculator. Okay? Go to second trace. And this time, make sure you pick, number 3, the minimum. Okay? Choose the minimum and hit enter. And then your calculator will ask you to go to the left side of the minimum. So I'm on the left side of the minimum, and I hit enter. Now my calculator says, go to the right side. So I go over to the right side of the minimum, and I hit enter. And then it says guess. Sure, take a guess, and you should get negative 0.78 negative 4.23. And that's the minimum, relative minimum. Everyone's calculator working now? I'll come help you in a minute. Okay, I'm going to do the summary, and then I'll come help you if your calculator is wrong. So here we go. We're going to put it all together. Suppose we have this polynomial set equal to 0. And if I were to factor this, this is x plus 4, x minus 1. Okay? So x plus 4 and x minus 1, these are called what? Starts with F. These are called factors of the polynomial. Negative 4 and 1, if we were to solve this equation, these are solutions to the equation. Okay? They are also the polynomial's zeros. We call them zeros now. You learned that today. And if we graph them, negative 4 and 1 are the x-intercepts. These are all kind of interchangeable here. They're solutions, zeros, x-intercepts. So if you had to graph this, you would know that negative 4 is an x-intercept, +1 is an x-intercept, and this is just a simple parabola. You can graph it very quickly.